Here's a simple exponential equation to solve. We have to try and calculate the value of x so that this equation is true. Now we can actually guess the solution. This is a good thing to do before you start, if it's easy. You might recognize that 7 to the power of 2 is 49. So this is close to the value of x we need. Because 7 to the x equals 50 in this case, we're guessing that x is bigger than 2, but not by very much. Anyway, this is how we solve it. We take logarithms of both sides to begin with. So log 7 to the power of x, and we do the same on the other side. Now I haven't said what base of logarithm we're using. It doesn't actually matter. We use one of the rules of logarithms to move the power to the front, so we can linearize the equation like this. And then it's just a case of making x the subject of this equation. So we divide both sides through by log 7. So what we'll get is log 50 divided by log 7. At this point you will use your calculator. Calculators usually have base 10 or base e, which is written as ln. If we use base 10 on mine, I'll find out that this is equal to 2.01038, and I could keep writing down more digits, but I'll just quote it to 5 decimal places. You can check the answers correct if you were doing an exam. If you put this back into the original equation and do a very quick calculation, 7 to the power 2.01038, well, because we haven't used an infinite number of decimal places, you're not going to get exactly 50, but it will be close to 50. So that's a quick check. Here's another simple exponential equation. This time the base is base e. So we're going to take logarithms just as we did before, but this time we're going to use the natural logarithm. Okay, so when we write it down, we're going to use ln e to the x, and we do the same with the other side. Take a natural logarithm, and it leaves us with that. Okay, now as before, we use the rule of logarithm, which says we can move the power, so we can write this as x ln e. And on the other side we've got the same thing still. Now at this point we can strike this out because we know this is equal to 1. Okay, and that leaves us with x equals ln of a half. Now this is the exact answer. If we wanted to do further calculations using this, we could just leave it like that. Or you could evaluate it on the calculator and you'll find that it's approximately, to a few decimal places, minus 0.6931. Okay, so this is the exact answer. This is the approximate answer to 4 decimal places. Okay, this is another exponential equation, but it's a bit more difficult than the ones we've looked at so far. This is actually a quadratic. It might not look like it at the moment, but we're going to try and write it so that it does look like a quadratic. So look at this first term. We can rewrite this using the rules of indices so that it looks like this. So instead of e to the 2x, we can have e to the x squared. So remember the rules of indices. If we had this, we would multiply the powers together to give us 2x. The rest of the equation, we'll just leave it as it is for a moment. So it's like that. Does it look like a quadratic yet? If we make a substitution, it should make it very clear that we have a quadratic. So if we change the variable, so everywhere we see e to the x, we change it for y. So this gives us 2y squared minus 5y minus 12 equals 0. So this is definitely a quadratic. Choose your favorite method for solving. Use the formula or complete the square. This is actually a nice one. It factorizes fairly easily. So hopefully you can figure out eventually that it's 2y plus 3 into y minus 4 equals 0. Now this means we've got 2 solutions, so let's examine them. So we've either got 2y plus 3 equals 0, so rearrange that to get y equals minus 3 over 2. The other one we've got y minus 4 equals 0. Rearrange that to get y equals 4. At this point we change back to the original variable. We need x, that's what we need to find. So this is what y is equal to. So here it means that actually e to the x equals minus 3 over 2. Now if you try to solve this by taking logarithms, you'll find that there are no real solutions. You take log of this side and log of this negative number, we won't get a real solution. So there are no real solutions for this particular equation. If we look at the other one, we've got e to the x equals 4. Now this is very like the second example we solved. So because it's base e, we're going to take logarithms of both sides. So we get ln e to the x equals ln of 4. Move the power to the front, it gives us x equals ln of 4. We get that because ln of e is equal to 1. So the solution to the original equation is equal to that, and we could use a calculator to change it to decimal form if we want. I think x is equal to 1.386, something like that.